Assalamualaikum. Bismillahirrahmanirrahim. Today we do physical chemistry numericals from chapter number 1, gases. In which we deal the question where we use the universal gas equations. Question number 96. Methanol is a common solvent used to make the detergents. If equation number 1, methane and water, carbon dioxide react with each other to form the carbon monoxide and hydrogen, then the carbon monoxide and hydrogen react with each other to form the methanol. It is the two-step process. Part A. In second reaction, how many megagrams of liquid methanol can be produced from 187 meter cube of carbon monoxide at 2.0 into 10 to the power 3 kilopascal and 500 Kelvin. Volume of carbon monoxide is equals to 187 meter cube. We know that 1 meter cube is equals to 10 to the power 3 liter. So it will become 187 into 10 to the power 3 liter. Pressure of carbon monoxide, which is 2.0 into 10 to the power 3 kilopascal. Temperature, which is 500 Kelvin. These are the given data. We know that PV is equals to nRT and N is equals to PV over RT. We put the values in this equation. We know that moles, we know that the pressure, which is 2.0 into 10 to the power 3 kilopascal, and volume, which is 187 into 10 to the power 3 liter. Universal gas constant that we use is 8.314 kilopascal liter per mole per Kelvin because the pressure is in kilopascal. The temperature is 500 Kelvin. We know that the per Kelvin is cut with the per Kelvin, liter with the liter, and kilopascal with the kilopascal. We are left with the one unit, which is the per mole. But so it is the unit of the moles. Now we solve these equations. (2.0) exponent 3 into 187 exponent 3, then divided by 8.314 and then divided by 500. The answer is 809,968 moles, which is the moles of the carbon monoxide. We know that from the second equations, we find that the moles of the carbon monoxides are equal to the moles of the methanols. Here, the 1 mole of carbon monoxide produce the 1 moles of the methanols. So 809,968 moles of carbon monoxide will also produce the 809,968 moles of the methanols. So the moles of methanol are 809,968, which are produced from the 809,968 moles of carbon monoxide. Molar mass of the methanols, we know that the mass of carbon is 12, hydrogen is 1, so we multiply the 1 with 3. The molar mass of oxygen is 16, and hydrogen is also 1. Now we solve this one, which is 12 plus 3 into 1 plus 16 plus 1. And the answer is 32. So the molar mass of the methanol is the 32 gram per mole. So the mass of the methanol is 32 gram per moles. We know that mole is equals to mass over molar mass. So mass is equals to mole into molar mass, where mole is 809,968 gram per mole and molar mass is 32 gram per moles. So when we multiply these, the answer will be 89968 into 32. And the mass is 2878976. So when we round off it, it will become the 2.2 into 10 to the power 6. 2.278976 into 10 to the power 6. So we can round off it to 2.9 into 10. We know that 10 to the power 6 is equals to mega. So the mass will be 2.9 megagrams. The part B. In second equation, what is the minimum volume of hydrogen gas at the 4.0 into 10 to the power 3 kilopascal and 500 Kelvin necessary to convert the 187 meter cube of the carbon monoxide gas as the 2.0 into 10 raised to power 3 kilopascal and 500 Kelvin. First of all, the volume of the carbon monoxide is 187 meter cube, which we know that 1 meter cube is equal to 10 raised to power 3 liters, so volume will become 187 into 10 raised to power 3 liter. Pressure, which is 2.0 into 10 raised to power 3 kilopascal, and temperature is 500 Kelvin. We know that PV is equals to nRT, and N is equals to PV over RT. Where pressure is 2.0 into 10 raised to power 3 kilopascal, volume is 187 into 10 raised to power 3 liter, and the universal gas constant that we use is 8.314 kilopascal liter per mole per Kelvin. And the temperature is 500 Kelvin. Kilopascal is cut with the kilopascal, liter with liter, and Kelvin with per Kelvin. We're left with only one unit, which is per mole. When it go the upside, it will become the moles, which is the unit of the moles of the molecules. Now we sort these equations, which is 2.0 exponent 3 into 187 exponent 3, then divided by 8.314, and then divided by 500. So it will be 89968 moles, which are the moles of the carbon monoxide. We had already defined it. So in the part you also find the moles of the carbon monoxide. When we compare the equation in which carbon monoxide and hydrogens are used to make the methanol, now we can see in the second equation, 1 mole of carbon monoxide react with the 2 moles of the hydrogen to form the 1 mole of methanol. So there we need 1 mole of carbon monoxide to react with the 2 moles of the hydrogen gas. If, for example, if there are 3 moles of carbon monoxide, they will react with the 6 mole of hydrogen. Okay, likewise, how much moles of the carbon monoxide, they will react with double the amount of the moles of hydrogen gas. Here we can see that the moles of the carbon monoxide and moles of hydrogen. 1 mole of carbon monoxide react with the 2 moles of hydrogen. So 89968 moles of carbon monoxide will react double the amount of 89968 hydrogens. So we can find this 2 into 89968, and then it becomes 179936. We can round off it to 8 into 10 raised to the power 5 moles of the hydrogen. So the moles of the hydrogen are 1.8 into 10 raised to the power 5 moles, and pressure is 4.0 into 10 raised to the power 3 kilopascal. Temperature is 500 Kelvin. We know that V is equals to nRT over P. We put the value into this equation, where moles are 1.8 into 10 raised to the power 5 mole. Universal gas constant is 8.314 kilopascal per mole per Kelvin, and temperature is 500 Kelvin, and pressure is 4.0 into 10 raised to the power 3 kilopascal. We cut the kilopascal with the kilopascal. Liter is the unit that are left, per mole is the mole, and per Kelvin is the Kelvin, and we are left with the only one unit, which is the liter. Now for these equations, (1.8 exponent 5 into 8.314 into 500. So divided by 4.0 exponent 3, and the answer is 187,065. We can write it 1.87 into 10 raised to the power 5 liter. Liter is just the unit of the volume, so volume will be 1.87 into 10 raised to the power 5 liter. This is the volume of the hydrogen gas that is react with the 1.187 into 10 raised to the power 3 liter volume of the carbon monoxide to produce the methanol. Thanks, and jazakallah khair for listening.